Hello everybody, and welcome back to the Poor Man's Chemist. In this video, I am going to be converting elemental tellurium, like you can see here, into ammonium hexachlorotellurate. Well, more properly, diammonium hexachlorotellurate, but everybody drops the di on the cation. I don't know why people do that. Even like Sigma does that. It's just so weird. But anyway, I have already made in a previous video ammonium hexaiodo-tellurate, and although it wasn't on a video, I've also made ammonium hexabromotellurate. I was hoping that ammonium hexachlorotellurate would be a quick and easy prep, a quick video that I could get out, no issues. Oh yeah, no such luck. In the past, I have converted tellurium chunks like this into amorphous tellurium powder by dissolving the tellurium chunks in sulfuric acid, taking the magenta colored solution that you get, dumping it into water, and you immediately get the conversion of whatever the hell species that is into amorphous tellurium. So if you don't use 98% sulfuric acid and you have to use something lower, like the 89% that I've got now, it takes forever. It's like trying to dissolve thallium in pure sulfuric acid. Oh my god, it takes for fucking ever. So I ended up having to find a better way. And what I came up with, what I discovered, was that tellurium will dissolve readily in hot aqua regia. You can then dilute that with water, neutralize it, and a white solid precipitates out. The identity of this white solid is not 100% clear. If the tellurium dissolving in aqua regia produces tellurium tetrachloride, that should hydrolyze in water to produce hydrochloric and tellurous acids. Tellurous acid isn't super soluble in water, but I don't necessarily think that the white solid dropping out is like tellurous acid or sodium tellurite. It behaves as if it is tellurium dioxide. It may be a hydrated tellurium dioxide. At any rate, whatever the hell this shit is, you can turn right around and use that to make ammonium hexachlorotellurate and presumably hexabromo and hexaiodo as well very easily. Like, this is so much easier than doing it from amorphous tellurium. I'm not even kidding. So because I had to find a way around the sulfuric acid problem, I ended up finding a much better way to do this prep in general, and the other two cognate preps were, the other two hexahalide complexes. So, yeah. I hope everybody enjoys this video. This is kind of a neat trick. If you want to try this yourself, tellurium, at least in the US, is readily available on eBay. Despite it being about as common as gold in the Earth's crust, it is not super expensive. I think like 10 grams costs about $5 or $6 the last time I bought it. With Bidenomics, the price, I'm sure, has gone up a little bit, but probably not dramatically. So, now that we've gotten all of that bullshit out of the way, let's do the prep. Alright, so here we go with dissolving this stuff in aqua regia. First thing we are going to do is add some hydrochloric acid to this. As soon as I make sure my wind does not blow my other pipette away. Okay. Gonna add some HCl. Obviously, this isn't gonna do much, if anything. Alright, maybe a little bit more. Alright. Hello. Okay, then. Condensation, that's fun. Well, for fuck's sake. There. You can see it kind of starts turning a little yellowish or greenish. I'm not really sure what's up with that. Now, here's some nitric acid. And as you can see, it starts to react pretty quick with that. This is fairly strong nitric acid. I actually don't know the molarity of it because I've never measured it. But it's pretty damn strong. Probably something 50-ish% or over. I made red fuming nitric acid and then I diluted it with a little water. Okay, now we're going to turn on the heat so that this does not take forever. And here we go. There we go. Now that it's hot, you can see the tellurium is dissolving quite vigorously. This is so much quicker than even 98% sulfuric acid. Like, this is the best way to dissolve tellurium that I've ever seen. Alright everyone, so almost all of our tellurium dissolved. I was able to separate out the tellurium that didn't dissolve. I have it right here. I just weighed it. This is 0.41 grams. We started with 7.4. There's a variance of plus 0.01 or 0.02 on the scale. So let's just say that 7 grams exactly dissolved. That sounds good. Also, happy to take the opportunity to once again dispel the myth that if you hold tellurium metal in your hand, you'll get tellurium breath. That is the stupidest thing I have ever heard. I've been holding this in my hand. I've gotten tellurium dioxide on my hands. I don't have tellurium breath. I don't know who started that myth. I think it was, touching organotellurium compounds or ingesting them can give you tellurium breath. You start exhaling dimethyl telluride. And somehow that has morphed over time to simply touching the fucking element will do this to you. Now, this stuff was kind of yellow. I just added a little bit of water to rinse it out of the small beaker and get it into here, and that was enough to turn it white. There was already a whitish solid in here. I'm not sure if that was tellurium dioxide or what it was. I'm not 100% sure what that was all about. We were getting a lot of white precipitate, so I diluted down the aqua regia with just a little bit of water, and that seemed to help and not help. Alright, so what we're going to do now is we are going to dilute this down with some more water. I'm going to rinse stuff off the sides. And it shouldn't, in theory, hydrolyze and drop a bunch of shit out. If it is dropping out as tellurium dioxide or tellurous acid, both of those should be kind of soluble in dilute nitric acid. See, it almost looks like it's clearing up ever so slightly. This is more in line with what I saw last time in the practice run. Of course, in the practice run, I only dissolved like 0.4 grams of tellurium, so there was a lot less of it. Anywho, what we need to do now is adjust the pH with sodium hydroxide to get it down closer to neutral, which will cause our probably hydrated tellurium dioxide to drop out. Here is our white precipitate that we will be using to make the ammonium hexachlorotellurate from. What I need to do now is filter this shit, which is fun since it likes to pass through filter paper. So, we'll filter this, we'll dry it out, and then we will go ahead and do the prep. The actual prep. Alright everyone, it is the next day. Here is our, well, I think tellurium dioxide. Come on, focus camera. It's very nice, very pretty, about exactly what I would expect. By appearance, it's impossible to tell. Tellurium dioxide should melt to give a yellow liquid at 700 something C. I tried that with the product that I've made this way, and I don't know, maybe it was a little windy, maybe I just didn't get the temperature quite up there, but it seemed more to just kind of char. But then when I dissolved that stuff that had charred in HCl and added ammonium chloride to it, I got ammonium hexachlorotellurate. So, like I've said before, I'm not sure exactly what it is, but it behaves as if it is tellurium dioxide, so we're going to go with it. Got 1.48 grams of it here. See, nice, got some little chunks. I don't know why I had the heat on, because I was making our ammonium chloride solution. This is 1 gram of ammonium chloride. That is 2 molar equivalents. Based on the amount of tellurium dioxide we have. It is saturated. I know it doesn't look like it right now, but it's because it's still warm. You have to make sure that the solution of the salt is saturated. It's not even a bad idea to add a little HCl to it, because water will rapidly decompose any hexachlorotellurate salt into the hydrohalic acid and tellurous acid. So you definitely don't want a high concentration of water at all, or your compound will immediately break down or just never form at all. Alright, so first step is to take our effectively tellurium dioxide. I'd really like to know exactly what the hell that is. I would have bet money it was tellurium dioxide. I'm going to add concentrated hydrochloric acid to this. You can see, well, you'll see it better if I zoomed in, that it immediately goes yellow. And that is tellurium tetrachloride being formed, or maybe hexachlorotelluric acid. I'm not 100% clear on that point. Doesn't really matter. Just going to add a good amount of HCl here. And again, this is just concentrated 31% or 31.45. We don't want to go too heavy on it because we are going to have to evaporate it down a little bit. Okay, now we have got to heat this up and stir it. One thing that I would recommend is that you keep this covered while you're doing it. Again, I don't know if any kind of tellurium species vaporizes out of here. If it ends up forming hexachlorotelluric acid, then probably not. But if it's tellurium tetrachloride in HCl solution, then it might. So I would just err on the side of caution. Okay, well, that actually dissolved pretty quickly. That only took about 30 seconds to dissolve, so that's convenient. Turn the heat off here. Now, my ammonium chloride solution, when it cooled down, nothing precipitated back out. It's so hard to get like a small amount of a salt to be right on the line of saturation, which is kind of what it needs to be for this. But one way that you can deal with that is to add a little bit of concentrated HCl. Now, that, of course, as you can see, will precipitate some of the salt back out. And then you can just add water drop by drop until it is right on the edge, which is what it needs to be. It can have too much water, but you can't have too much HCl, because water will decompose our product rapidly. Okay, it is right on the line. There is only a tiny amount of solid left in there, almost completely gone. Okay, here we go. Moment of truth. Now, what we are going to do is we are going to add that to our solution here. I don't expect anything to precipitate out immediately. Of course, I say that, and because I've said that, it probably will. Alright, it's actually cooperating. Now we're going to just rinse that into there with a little bit of hydrochloric acid. Rinse the beaker out and add a little bit in there. There we go. Alright, now what we need to do is heat this puppy up. Now, the textbook says to let it sit at this point, and our salt will slowly crystallize out over the course of a couple hours. It might if you leave it sit here long enough, but I am not a patient man, and there is an easier way to get it to crystallize quickly, and that is just to heat it up and evaporate it down until you just start to see crystallization, like the very beginnings of it, and then take it off the heat. That's what I did in the practice run, and that seemed to work really well, so we're going to try that here. So, I am going to heat this up, and as soon as I start seeing crystals form, I will come back. All right, everyone, there is our product. It is nice and sparkly and beautiful. I let this beaker chill in ice for a little while to get as much as possible to crystallize out. You can see we got a fair bit of it here. The liquid we will have to filter off. The textbook says ammonium hexachlorotellurate is stable-ish in air. More so than the alkali hexachlorotellurates. I'm not sure about the cesium salt, since the cesium salts tend to be kind of a little more stable than I would expect like potassium to be when you're talking about compounds like this. But on the other hand, hexachloroselenate is very similar, and the cesium salt isn't really stable there either. I am dubious that this stuff is going to be totally happy about being in air, but we are going to try it anyway. I was very tempted just to store it like it is. Like, this is how I've stored the ammonium and cesium hexachlorosenates. They're just stored under the solutions that they were made in order to prevent decomposition. But we're going to give this a try. I mean, what have we got to lose, right? The liquid, the filtrate, once we're done with it, that can go into recycling because, you know, you just add water and if need be, adjust the pH and you can get the probably tellurium dioxide right back out of it again. So very easy to recycle. Anyway, here we go. We're going to give this a try. Okay. All right. And of course, it's got to be tree jizz. That's okay, because an ant fell into the fucking beaker earlier. Because of course it did. I don't even know where that fucker came from. Alright. Come on, filter paper. There we go. Okay, so far so good. Very nice and crystalline and pretty. Is it showing up well? It probably isn't. Oh well. I really hope this is focused. Alright, and we're going to do our usual... Ooh, yeah, maybe not totally happy with air. It's okay. It's alright. I think that... It just looks like it's getting a little whitish on the top, and that's probably not a good sign where it's pulling air through it, but I think that we can fix this problem here. A little more of our solution. Yep, there's that fucking ant. God damn you, ant. See? Right fucking there. Right there, little bastard. Alright. We will not draw any more air through that, and we are just going to scoop this shit into a vial and hope that we can get it in there and that it stays happy from this point out. Although it probably won't. Alright, everybody. There we go. There is our final product. It is a nice, beautiful, vivid yellow color. Here it is in the vial. You can see there's a little bit of condensation on the vial. That's hardly surprising considering it was not super dry. I don't want to try to super dry it because I think you'd have to do it under an inert atmosphere in order to make it happy and I didn't really need this for anything. I made it just purely for curiosity's sake. Now I can say I've made all of the hexachlorotellurates. That's pretty cool. I don't know anybody else that can say that. Although Tellurium is very cheap, guys. I mean, I got this off eBay from my usual element vendor, JD Chemist, just because his stuff is always very reasonably priced and it's always very good purity. He never mixes stuff up. He never rips me off. He never sends me the wrong thing or anything like that. And shipping is always free. So, yeah. At least if you live in the U.S., it should be reasonably easy to get some chunks of tellurium and, make any of these hexachlorotellurate 4 salts. That tickles your fancy. So, anyway, that was a pretty neat compound. And look at it. It's such a beautifully vivid yellow color. I don't know. How does that compare to rubidium hexabromophthalate? That's my gold standard for yellow. Let's see. How do they compare? No, they're both vivid yellows. Yeah. A little bit lighter, I guess. Maybe almost, I don't know. Call it, I don't know what kind of yellow you call that. But whatever it is good. Yellow chem is good. What can I say? So anyway, if you guys like this video, give it a thumbs up. And if you didn't like it, well, I don't know what to say about that. Subscribe, comment, share the video. Check out the backup channel. I have been trying to upload anything from 3 to 5 videos there a day of all of the old stuff. I am definitely going to get back to my roots because as I've been looking at that stuff, I'm like, man, I think I lost my way somewhere along the way here. We need to get back to making more edgy stuff, that's a bit more on the naughty side. Just because it was more fun. And if YouTube gives me another strike, well, who the fuck cares, man? YouTube is brain cancer. So, anyway, until the next one, you guys, I will see you later.